Hello everyone. Today we'll be solving EDEXCEL IGCSE 921 Chemistry Paper 1C Jan 2022 question number 8 to question number 11. Today we are solving the part 3 part of this particular question paper. So let's jump right in. All right. Question number 8 is a organic chemistry related question paper. So the table shows the structure of 6 organic compound. The first structure that we are looking at a uh, 2-methyl propane. Then we can see that we are looking at there are 4 carbon in a row. Okay, so that means it's a bute. So there is a carbon-carbon double bond in the first carbon and in the third carbon. So bute 1, 3. We are looking at a diene, dialkene. Then the next one that we are looking at, we have 5 carbons that are in a cyclical format. So this is cyclopentane. We have methane in F. Then we have propene in E. And then we have butane. We're just naming them so that it makes it easy for us to do the answers. Give the letters of a compound not shown as a displayed formula. So we can see this particular part of the methyl group is not shown as a displayed formula. So we can name, yes, so A will be that particular compound. The next, give the letter of a saturated compound with general formula CnH2n. In the case of number B, we have but 1,3-diene. Diene does not have a general formula CnH2n. So it will be propene. That will be the answer. So E. Part 2. Give the letter of a saturated compound with the general formula CnH2n. Since it says saturated compound, that means the carbon must have carbon-carbon single bond only. And it also has to be CnH2n. All right. So we know that cyclic alkane, they are the only ones that can meet that particular criteria, because there are, if we count in here, there is 5 carbons and there is a total of 10 hydrogens, so which meets the general formula CnH2n. All right, and it has all carbon-carbon single bonds. That means it is saturated. So C will be the correct answer. Name compound E. So E is basically propane. We already named it. Next, explain why compound A and compound D are isomers. So compound A, let's see the formula. We can see it's C4, and then it's a total of hydrogen H10. We can see there is a total of 10 hydrogens. All right, and then compound D, butane, it also has C4 and H10. So yes, they are isomer of each other because they have the same molecular formula but different structural formula. Part B. Compound F reacts with bromine in the presence of ultraviolet radiation. Complete the equation for the reaction. So if we react methane with bromine, in presence of UV light, we are going to get bromomethane and HBr. The question says, give the name of this type of reaction. This type of reactions are called substitution reaction because the hydrogen is substituted by the bromine. Part C1. Another compound G has this percentage composition by mass. C 37.8, hydrogen 6.3, chlorine 55.9. Show by calculation the empirical formula of the compound GC2H4Cl. So the first step should be divide percentage by AR. So for the case of carbon, it is 37.8 divided by 12, hydrogen 6.3 divided by 1, chlorine 55.9 divided by 35.5. So we get 3.15, 6.3, and 1.57 respectively. Then we are going to do simplest ratio, or divide by the smallest number. So the smallest number in all of this is 1.57. So we're going to divide it by 1.57. That gives us an answer of 2, 4, and 1. So the empirical formula C2H4Cl. So they asked us to show, so it's shown. The relative formula mass of G is 127. Determine the molecular formula of G. So when information like this is provided, what we have to do is basically, first of all, we will calculate the MR of the empirical formula. The MR of C2H4Cl. So there will be 12 into 2, 1 into 4, and 35.5, which gives us a total number of 63.5. Then we just do a simple straightforward division with 127 divided by 63.5. That gives us a value of 2. So the molecular formula, we just multiply it, C2H4Cl, we multiply it with 2, and we get C4H8Cl2. Part 8. Compound E is used to make an addition polymer. Complete the equation to show the part of the polymer formed from 2 molecules of compound E. So we must notice the carbon-carbon double bond. That is our main goal. The carbon-carbon double bond, we just have to imagine that it was centered over here. It was centered over here. Now the double bond disappeared. So we will have to understand that one of the carbon contains a CH3. So we will write that CH3. And we'll make the double bond disappear because they have already formed the new bonds. These bonds are formed when the double bond disappeared. These hands were formed. So we'll let it be in that way. So that's how you do it. Next question. Give one problem caused by disposal of addition polymer. We know that addition polymers, the polymers that are formed, they are mostly non-biodegradable. So they will, fill up landfill sites. They will emit greenhouse gases when they're burnt. So these are the problems. Question number 9. A student uses this apparatus to investigate the rate of reaction between calcium carbonate chips and dilute hydrochloric acid. We can see that there is a plug. So the plug is always present because we want to prevent spitting of the chemical. All right, calcium carbonate chips, dilute hydrochloric acid, and we can see the balance. So as the the carbon dioxide will be produced, the carbon dioxide will escape the system, and the mass of this particular entire apparatus is going to decrease. Now the question says every 20 seconds the student records a reading of the balance. Explain why using a cotton wool plug increases the accuracy of the student's result. So guys, that's I was saying, because it prevents the acid splashing or spitting. All right, and the carbon dioxide gas can easily escape. So the decrease in mass is close to the actual value. All right, and thereby it makes it a very good experiment. Part B. Complete the equation for the reaction by adding the state symbols. Calcium carbonate with hydrochloric acid, calcium chloride plus water plus carbon dioxide. So calcium carbonate is basically solid, and hydrochloric acid is obviously it's an acid, so it's an aqueous. Calcium chloride is aqueous. Water is definitely a liquid. All right. and CO2 is a gas that is produced. The student uses the balanced readings to find out the decrease in mass of the flask and content. The graph shows the student's results. As we can see, as the time is increasing, the decrease in mass, we can see initially the decrease in mass is really fast with increase in time. However, then it slows down, and after that it plateaus, which indicates that the reaction has finished. And we can see the time when the reaction has finished, we can consider is 100 seconds. This is the point where the reaction has finished. The question says, give a reason why there are some calcium carbonate chips remaining in the flask when the reaction stops. Because we added excess calcium carbonate, all right, to make sure that all the hydrochloric acid is reacted. All right. So, that's what it indicates. Part 2, state how the student would know when the reaction has stopped. The student is going to know because, whenever calcium carbonate reacts with hydrochloric acid, it produces effervescence. All right. And other way the student is going to know is when the decrease in mass is going to stop. Use the graph to determine the amount in moles of carbon dioxide produced during the reaction. Okay, so we can see there is a total of mass lost up until this particular point when the reaction stops. So basically 0.92, 0.9, 0.92, 94, 96, 98. So this is 0.98 lost, decrease in mass. So 0.98 divided by 44 equals to 0.022 moles. So guys, part 4. Use the graph to calculate the rate of reaction in grams per second at time equals to 60 seconds. Show you're working on the graph. So basically what happens is that at time is equals to 60 seconds, we'll have to do a tangent to show the rate. To find out the gradient, we'll have to do the rise over run. Now the rate of reaction is basically the tangent. So rate of reaction is equals to y2 minus y1. So 1 minus 0.6, 1 minus 0.6 divided by 80 minus 0. This is the gram, this is the second. So the rate comes 0.005 grams per second. Part D. The student repeats the investigation by diluting the original hydrochloric acid. The student then determines the initial rate of reaction at different percentage concentrations of the original hydrochloric acid. The graph shows the student's result. Initial rate of the reaction and percentage concentration of original hydrochloric acid. So as you can see, if we use the 100% of the original hydrochloric acid, the rate of the reaction in the beginning is really high. But as we keep on decreasing, that rate of reaction decreases until it reaches 0. And the question says, describe the relationship between initial rate of reaction and percentage concentration of original hydrochloric acid. So we can see as the percentage concentration of original hydrochloric acid increases, rate of reaction, the initial rate of reaction also increases. Now, so it is directly proportional, as we can see from the graph. Part 2. Explain why changing the concentration of hydrochloric acid has an effect on the initial rate of reaction. So basically, changing concentration, if we decrease the concentration of hydrochloric acid, there is a change in number of particles per unit volume. There is a decrease in number of particles per unit volume. So which will lead to a change in collision per unit time. Question number 10. This question is about substances with covalent bonds. The question says, draw a dot and cross diagram to show the outer shell electron in a molecule of nitrogen. So to show that molecule of nitrogen, one of the molecule must be used as a dot. So one nitrogen will contain total of 5 electrons. The other nitrogen will contain a total of 5 electrons. So 3 electrons are shared between them. Describe the forces of attraction in covalent bond. So basically the forces of attraction in a covalent bond arises from the shared pair of electron, which is then attracted by the 2 nuclei. The diagram shows 3 different structures of carbon. So in structure A, we can see this is diamond. In structure B, we can see graphite. And graphite, we can see layers that are forming. And then there is delocalized electron in between the layers. And in structure, in the last structure, we can see fullerene. All right. So the question says, name the structure A. Okay, diamond. Part 2. Graphite and C60 fullerene contain covalent bonds, but have different structures. Explain why C60 fullerenes have a much lower melting point than graphite. Refer to the structure and bonding in your answer. So basically, if we look into a graphite, the graphite produces a graphene layer, and each graphene is attracted to another graphene, all right, by means of delocalized electron. There is a higher amount of attraction between each other because there is a greater amount of surface area that is in contact with each other. So graphite has more attraction between the layers. Whereas in case of a fullerene, which is a circular structure, its contact with the next fullerene is much, much, much lesser than that of the graphite. All right, which makes it easily, which causes it to sublime easily. So guys, basically graphite is a giant covalent structure. So during melting, the graphite covalent bonds needs to be broken. Whereas a C60 is a simple molecular structure. In melting, C60 intermolecular forces of attractions are overcome only. So more energy is needed to break the covalent bonds in graphite than the intermolecular forces in C60. We know that covalent bonds are always stronger than intermolecular forces. Question number 11. A student uses this apparatus to heat crystals of hydrated zinc sulfate and collect the liquid produced. So hydrated zinc sulfate, it's heated and colorless liquid obtained. Describe a chemical test to show that the colorless liquid contains water. To do a chemical test for colorless liquid and to show that it's water, we can use anhydrous copper 2 sulfate. We know that anhydrous copper 2 sulfate has a white color, and then once we add it to water, it turns from an white color to blue color because it itself gets hydrated. Describe a physical test to show the colorless liquid is a pure water. So the physical test for proving anything that is pure is boiling point and freezing point. So we need to measure the boiling point and freezing point. Part B. The equation for the decomposition of hydrated zinc sulfate is ZnSO4 7H2O, which is heated, turns into ZnSO4 and gives off the 7H2O as liquid. All right, or maybe at that time it goes away as steam. The student records these masses. The mass of boiling tube 41.64, mass of boiling point tube plus ZnSO4 7H2O 54.46. Okay, calculate the maximum volume in cm cube of pure water that could be produced. Give your answer to one decimal place. 1 cm cube of pure water has a mass of 1 gram. MR ZnSO4 7H2O 287 and MR of H2O is 18. All right, so all of the informations are provided. First of all, we need to know the mass of the hydrated zinc sulfate. Then we need to find out the number of moles of hydrated zinc sulfate. So 12.82 divided by 287. We get the number from here. 287, which is equals to 0.0447 moles. Now, if you notice, 1 mole of ZnSO4.7H2 produces 7 moles of water. So this indicates that we can find out the number of moles of water. Then we can find out the mass of water, which comes 5.63. So since we need the volume, and we know that it is 1 gram per cm cube, so 5.63 grams are divided by 1 gram per cm cube, which makes it 5.6 cm cube. We are asked to give the answer to the nearest 1 decimal place, which is why we cannot accept this particular second decimal place point. So 5.6 cm cube. In an experiment using different mass of ZnSO4.7H2O, the maximum volume of pure water that could be produced is 8.5. The student collected the pure water and calculated the percentage yield to be 20.3. Calculate the volume in cm cube of pure water collected. Since we can produce the maximum mass, which is like the theoretical yield should be 8.5 cm cube. However, the student had only 20.3% yield. So 8.5 into 20.3% will be equal to 1.7. So the volume of pure water that the student can achieve is 1.7 cm cube. Last question. Explain an improvement to the apparatus that would increase the percentage yield of pure water. So basically, we can see in this particular apparatus that water was directly collected. Now, if water is collected directly in this way, most of the water will be lost as water vapor. So we can put this particular measuring cylinder in an ice cold, in a particular water bath which has a temperature of 0 degrees Celsius, to make sure that all of the liquid, all of the gas, water vapor that comes out can condense. So we can say, stand the measuring cylinder in a beaker of ice. This can be an improvement. Other than that, we can replace the delivery tube with a Liebig condenser. Guys, that's all for the today's video. Thank you for joining. Please like, share, and subscribe this particular channel. And see you in the next video. Bye bye.